Hi everyone, just wanted to take a minute to talk a little bit about kites. So kites are our final type of quadrilateral that we are going to be talking about, and they are kind of the furthest away from the other ones. And the reason they're the furthest away from the other ones is that we will have no parallel sides now. So parallelograms, remember we had two sets of parallel sides. In trapezoids, we had one set of parallel sides, and now in kites we will have none. They do have some interesting features though. The consecutive sides would be congruent, right? We would have two pairs of consecutive congruent sides, so the two at the top and then the two longer ones at the bottom will be congruent. We'll also know that the diagonals will be perpendicular. That actually comes from the perpendicular bisector theorem. If you know that these are equidistant, right, it would be on the perpendicular bisector. So what else do we know? We know that one diagonal will be bisected, this one. The short one will be bisected. We know that the opposite sides over here are going to have congruent angles. The diagonals will also bisect these angles. So there's a lot happening with kites, but we're really not going to do a whole lot with them, just because they're kind of their own thing. And for us to, just kind of have to remember just something for the sake of remembering it, I would rather focus on other things. So let's move on. We'll do some practice and make sure we're good to go. So what do we know? This is a kite. So what does that mean about these sides? Well, that means this one and this one are congruent. That means this one and this one are congruent. Okay, so I would know that 4x plus 1 is equal to 17. Similarly, I would know that 6x minus 3 is equal to 21. So 4x equals 16, x will equal 4. Okay, so let's just confirm 24, x will equal 4. All right, so x equals 4. Now, what do we know about these? Well, we know that the diagonals are perpendicular, so if this angle is right here, it must be a right angle. Okay, it must be a right angle, so that means 90 equals 6x plus 6. So 84, equals 6x. And if I am correct, 84 divided by 6 is the 14. Okay. So that would be how you would find that. So remember, right angle, congruent. There's a number of other things we could have done as well, right? I could have figured out, I know that these two are bisected. I know that this is equal to this. I know that this whole angle up here is the same as this whole angle down here. So there's a lot of stuff I could have done. Now, on this one, my goal is to find all the sides. Well, how can I find all the sides? Simple enough. These are right angles, right? These are right angles. Because those are right angles, and I know that these are right triangles. So that would mean this side over here, SV, right? That's just going to be equal to, that's the hypotenuse. That squared is equal to 8 squared plus 9 squared. So SV squared is equal to 64 plus 81. So SV squared is going to be equal to, what's that? 145. So SV squared is going to be equal to the square root of 145. Well, let's ask ourselves, is there anything I can do with the 145? 145 divided by 5 is 29, so I actually have to leave that alone. Now, if this is the square root of 145, this is the square root of 145. All right. Now this one, we have 7 and 9. So 7 squared plus 9 squared, and that number, I think it was a u, or letter I should say, is equal to tu squared. Okay, so that would be 49 plus 81 is equal to tu squared. So what's that going to be? 130 equals tu squared. Let's just make sure I added right there. 81 plus 49, 130. Okay. So can I do anything with the 130? Well, that's 10 times 13, so no, I cannot. So this is going to be the square root of 130. right? So that's the square root of 130, which means this is also the square root of 130. So when in doubt, if you don't know the sides, but you know some of the pieces on the inside, you'd be able to use the Pythagorean theorem. Now, the last thing I want to go over is we need to talk a little bit about how to find if something is a kite using coordinates. All right, so let's go back up to the top. What do we know about kites? Well, we know a number of things. We know they have pairs of consecutive congruent sides. So we would need to use the distance formula for that. We have perpendicular diagonals. Now you do need to be careful. We do remember that certain diagonals in parallelograms are perpendicular, particularly the rhombus. So you do need to be careful, because if I just do that without showing that it's not a parallelogram, I technically haven't completed my piece of information, right? So you should always start off by showing that this is not going to be a parallelogram. So let me just confirm that, and I'll show you what I mean. Okay, so everything's in the first quadrant. So we have this point over here, over 5, up 5, over 8, up 4, over 7, up 1. Now, clearly, this is not going to be a parallelogram, but let's just confirm. Okay, so how would I confirm? I'll just A, B, C, D, A, B, C, D. Okay, so let's find the slope of AB. 5 over 5, right? 5 minus 0 is 5 over 1. Let's find the slope of BC. Let's just go all the way around and draw the slope. Okay. BC. Change in y is 5 minus 4, 5 minus 8. Going to be negative 1 over positive 1 over negative 3. So negative 1/3. Slope of CD. Change in y, 4 minus 1, 8 minus 7. Going to be 3 over 1. All right, and then interestingly enough, those are going to be perpendicular. Huh. BC and CD. Neat. All right, anyway, and then let's see, what do we have, DA? All right, so change in y is going to be 1 over 7, so it'll be 1/7. Okay, so as you can see here, none of these are going to be parallel. So this is not a parallelogram. So far, so good. And it actually has no sides. So it's either going to be nothing, in terms of what I mean by that is it's just going to be a straight old quadrilateral and nothing interesting happening, or it's going to it could be a kite. So how would I figure out it's a kite? Well, I can look at the distances. I can look at A, B, and AD and see if they're the same. I can look at BC and BC and CD, and I can figure out if they're the same. Or alternatively, I could use some of the other methods. What are the other methods I know? Well, one diagonal is bisected, and one pair are congruent, or we have perpendicular bisectors. So let's look at it, and let's go through the process of looking at the lengths. Okay, so let's look at the lengths. So let's look at AB. Now, conveniently, this is 0, 0. So what do we know about that? That's going to be a change of 5, right? So 5 squared plus 5 squared is going to be the square root of 50, which is equal to 5 root 2, right? Because 50 is equal to 25 times 2, so 5 root 2. AD, now these should be the same if this is a kite. Square root of 7 squared plus 1 squared, which is going to be the square root of 50, so we are good. Okay, so far so good. We know these are congruent. Now we need to show that BC and BD are congruent. So BC, square root, change in x is going to be 8 minus 7 squared, 4 minus 1 squared. I'm going to move my head over here. And that's going to be equal to square root of 1 plus 3 squared, so the square root of 10. So if we do this correctly, this should also be the square root of 10, assuming this is a kite. I don't think it would be possible for us to show that it's not a kite otherwise. But anyway, let's go through that process. Okay, CD. Oh, did I just do CD? That's actually CD. Oopsie. BC. So that one's CD. So BC would be the one with the 5s. Okay, so we would have 8 minus 5 squared plus 5 minus 4 squared, which is equal to 3 squared plus 1, which is going to be equal to the square root of 10. So ultimately, because these are congruent, this is going to be a kite. So that one is kind of one of the longer ones. Again, you could have used some of the other methods, but I wanted to make sure we were clear on the distance formula. Remember, and please remember this, you can kind of shorten your time with dealing with the distance formula if you look over at the slopes, right? You know we're going to, basically what is the distance formula? You're doing the square root of the change in x plus the change in y. Well, you calculated the change in x and the change in y over here, so you can start reusing things. Just be careful, do it before you simplify it. Now, anyway, that is how you would show that something is a kite. Let me know if you have any questions, and have a great day.